Try to solve another Leetcode problem. 18, 40, 64. Minimum number of swaps to make the binary tree alternating. So the idea is that we are giving a tree S. It can be 0 and 1, and we just want to swap 0 and 1 or 1 to 0 to make the tree alternating. If it is not possible, we're going to return a -1. So this is the example 0, 1, 0 or 1, 0, 1, 0. Yeah. While 0, 1, 0, 0, so this is not alternating. So any two characters may be swapped even if they are not adjacent. So this means for the first example, this one can swap with this 0 and there's only one swap. So we're going to return the minimum swap. Yeah. Now if you understand the problem, normally how you're going to solve this problem. But before you solving the problem, you need to check what's going to be the length of the string. So that is 1000. Yeah. And SI is only 0 and 1. So what we can do, so we need to know what gonna be the final state of the string after swapping. So after swapping, it can be 0, 1, 0, 1, 0 with something, or it can be 0, 1, 0, 1 and something. And in which condition we're gonna swap 0 to 1 or 1 to 0? Definitely we don't need to swap 0 to 0 or 1 to 1 because it is not necessary. Yeah, we only need to swap with 0 to 1 or 1 to 0. So this is only what we're gonna swap. But in which position we're gonna swap? So if the example is like 1, 0, 1, 0, do we need to do any swap? No, we don't need it. And if it is like 0, 1, 0, 1, do we need to swap it? No, we don't need it. Yeah. So this means we're gonna we're gonna solve the problem according to different cases. So the first case is that we're gonna set the final string. It's gonna be 1, 0, 1, 0. The second condition is that we're gonna set the string to be 0, 1, 0, 1. Yeah. So this means, so for example, in the first example, so this means in the even index, it's gonna always be 1. Yeah. So this is the even index. It is 1. This is okay. And for the next one, maybe, yeah, this is the even index. What happens if it is a 0? Yeah. And here is a 1. This is the odd index. Here is 1. What gonna happen for this kind of a situation? Definitely it didn't work. Yeah, but if we swap this 0 with this 1, definitely it works. Yeah, it works. So this means we're gonna count the even position and odd position. So this is gonna be the even position. So if it is 1, it is okay. If there is a 0, so we're gonna count it as 1. Yeah, so this means definitely I need a swap. Yeah, and then we're gonna count the odd index. We're gonna check how many ones in the odd index. So this is 0, okay, 0, okay. This is 1. So there's a 1 at odd index. So this means this one gonna swap with this one. So this means how many swaps? It is a 1. So if they are not equal, definitely it's not possible. We're gonna return a -1. So this is the whole idea for solving the problem. Yeah. Now let's just solve the problem. So the first condition is gonna be 0, 1, 1, 0, 1, 0. Yeah. So we're gonna prepare a count. So the final result, I'm gonna set it as -infinity because I'm gonna check the minimum. Yeah. So I'm gonna count the 1 and 0. So how many ones at the so currently I want to count how many ones at the even position, at the odd position, because it should be 0, but I want to check how many ones. So it's gonna be s with 1, 1. It's gonna starting from 1 and it's gonna have a step up 2. Yeah, starting from 1 step up 2. So I'm gonna count how many ones. And similarly for this 0, I'm gonna count how many zeros, but it's gonna count from the even index. So yeah, I'm gonna count how many zeros. So I'm gonna have a check. So if 1 equal to 0, so this means I'm gonna set the result. It's gonna be the minimum of the result with this one. And similarly, let me just copy the code and do another check. So because this is gonna be the condition of 0, 1, 0, 1. Yeah. So this is gonna be the 1. So I just need to check. I can change it to I can change it from here. So I can change it from here. So this means from the even position, I want to check how many ones, and from the odd position, I want to check how many zeros. Yeah, so this is the odd person. I want to check how many zeros. If they're equal, I'm gonna check the minimum. So finally, I'm gonna return the result. If the result not equal to negative infinity, yeah, it should be the positive infinity because I'm calculating the minimum. Yeah, right. Else, I'm gonna return negative 1. So this is the whole idea for solving the problem. As you can see, it works. Yeah. Now let me just submit it to prove that it can pass. As you can see, it's pretty fast, and it passed for all testing cases. And the time complexity is just O(n). N is the length of the string, 1000. I think that's all about this problem. Thank you for watching. See you next time.